In stats, we pressed on with transforming random variables. We had done all of this, and we were on this page today. So the two formulas you see right here and right here, we used those yesterday. We used those on the previous page. And it may look foreign to you, but it's all based on Algebra 1. So remember that from Algebra 1, mx plus b, y-intercept form, slope-intercept form, sorry. So in stats, they change it to this. So I don't know why, but in stats, they call b the slope and a the y-intercept. We did this in linear regression. It should look really similar. And when you get the mean of that function, all you do is you plug in the mean of x. So you'll know the slope, you'll know the y-intercept, and you just plug it all in, and you get the mean of y. Be careful with standard deviation. You ignore the constant, all right? So the y-intercept has no effect on standard deviation. All right? So, it's typed right there, but standard deviation of y is absolute value of the slope times standard deviation of x. And that's it. So let's give it a try. We have this baby's RS problem. We have this bathtub that has a baby safe setting. It is in Celsius. It tells us that this temperature X is normally distributed with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. But we're worried about Fahrenheit because of this baby's RS claim on part B. So it's asking us to convert it to Fahrenheit, and we're calling that y. We're calling that variable y. All right? So let's write this, since x is normal and y is dependent on x, y is normal too. All right, so we can say y is normal. We need to find the mean of y and the standard deviation of y. So to do that, we use the formulas typed right up there that we used yesterday. So we have our function. I'm going to change the f to a y because that's kind of confusing. And the c to an x. Because Celsius is C. I don't know why they used all these different letters in this problem, but we typically use X and Y. So when I get the mean of Y, I'm going to plug in the mean of X, and that is 34, and type it into my calculator. When I do that, I get 93.2. For standard deviation, we're just going to multiply 9/5 times the standard deviation of x. So what was that? 2. So standard deviation is 18/5, or 18 over 5, or 3.6 degrees Fahrenheit. And we have defined the distribution of y. All right. So part B, Babies R Us makes this claim that bathwater should be between 90 and 100 for babies. There's the baby safe setting on the bathtub, so we want to see what is the probability that baby safe falls within the recommendation 90 to 100. Long story short, we want the probability of the temperature being between 90 and 100 degrees Fahrenheit. We know Y is normal, so let's find some Z-scores. And we end up with negative repeating 8. Let's find 100's Z-score. And we get 1 point repeating 8. Then I'm going to pull up normal CDF on my calculator. Type in those two Z-scores, leave mu and sigma alone, 0 and 1. And we end up with a probability of 0.7835. And that's it. We moved on and we talked about the combination of multiple random variables, and this is pretty complicated here. All you do for the mean is very, very simple, is you plug in the means. So to find the mean of a function with multiple variables, just plug in the mean of those variables. It's almost too good to be true. And it's typed right above this. Right here. So if I know we have a function, t is x plus y, right here. If I want the mean of t, I plug in the mean of x and the mean of y, done. Add them together. Same with the difference, plug in the mean of each and subtract. Standard deviation is a little different. There are two things to consider. For standard deviation, of a function with multiple variables the variables must be independent. So I made that in bold. It's right above this. Must be independent. Also, you have to get the variance, then add the two, or however many you have, get them together, then you have the variance of the whole function, and then square root. So square each standard deviation, add, combine, whatever, then square root. My example on that is a right triangle and Pythagorean theorem. If we're looking at a 3, 4, 5 triangle, the way you get the hypotenuse is Pythagorean theorem, right? 3 squared plus 4 squared equals c squared, and c equals the square root of 25, right? Same exact concept for standard deviation of a function. If I want the standard deviation of t, I need to square the two standard deviations, add them together, then square root. All right, let's give it a shot. Pete has a sister named Erin. I'm going to zoom out a tiny bit. So we've already done the top of this page. That's from yesterday. Pete has a sister named Erin who lives in another part of the country, and she's going to start her own Jeep tour business. And based on her business, she has that distribution right there. So I did a little bit of math for us, and there's our mean, there's Erin's mean and standard deviation, and so is Pete's right above it. We didn't quite get to the bottom of this page, so I'm going to zoom in. Well, I think I'll just leave it like that. We need, I forgot to type it, find the mean and standard deviation of t. So to get the mean of t, notice we have a function right here, right? We're going to plug in the mean of x and the mean of y. So if you want to write this line right here, you can. But here's how we do it. We plug in 3.75 and 3.1, add them together, and we know the mean of t is 6.85. And that is it for the mean. Very simple. For the standard deviation, they have to be independent. So maybe skim the paragraph. Is there something that implies independence or dependence? Right there. Implies independence. So for standard deviation, Pete and Erin's passengers are independent. So this is just like the Pythagorean theorem. I need to get the variance of t by plugging in standard deviation, squaring it for Pete and Erin. All right, so we're going to go 1.0897 squared plus 0.943 squared, and that's going to give us, I think I wrote it down, 2.0767. Then square root it, and we get 1.4411. And that's it. That's as far as we went today. I'll see y'all later. Bye.